Alright, welcome to the solutions video. I'll do a little bit explaining for some of them, but for the most part, I just have the answers there. So you should check your work, and if you got any wrong, go back, figure out how you made an error, why you made an error, correct it, so that you don't make that same error tomorrow. Alright, first thing, number one, this should be seconds, not feet. That's just a typo. Hopefully you figured that out. For part E, the question is, when will you change direction? So you can imagine and it's helpful if you have graphed this first. Your velocity at the beginning is going to be negative. And so if you think about, for example, imagine that you're traveling and you can either travel left or right. And traveling left would be a negative direction and traveling right would be positive. Well, then you're traveling to the left for a while, and then at some point you're going to start traveling back to the right. Well, at that moment when you switch direction, your velocity is going to be hitting 0. And so your question will be, that you need to answer for yourself is, when will the velocity be equal to 0? And so you set the velocity equal to 0 and solve for t, and you get that t value will be 1.5 seconds in. And you can see that makes sense. At 1.5 seconds, your velocity is changing from a negative velocity to a positive velocity, and so it'll be changing direction. For number 2, a cube is just a rectangular prism where all the dimensions are the same, the side lengths are all the same. So the volume is just s cubed, and then you can take the derivative of the velocity with respect to the side length, which is just 3s squared. That's in inches cubed per inch. This is a measure of volume, and this is a measure of the side length. And then if you find the derivative, the instantaneous rate of change when s equals 1, that would be 3 inches cubed per inch. And when the side length is 5, it would be 75 inches cubed per inch. All right, I can't stress how important number 3 is. If you go into the test with only one true piece of understanding, it should be the understanding of the limit expression of a derivative. In other words, the definition of a derivative. And if you understand that truly and deeply, you can actually figure out everything else that was covered in the unit. In other words, you can solve any problem that is presented. Obviously, it would be helpful to understand the other ideas that we talked about, but the number one idea from which everything else stems is the definition of a derivative and the understanding of why the limit expression works. So if you need to, go back and rewatch the first lesson of the unit where we define the derivative and talk about the limit expression. And what we do is we connect the graphical representation to the limit expression, and that is where the understanding comes in, where you understand why the limit expression works. So go back and take a look at that. Now, for number 4, this is a particularly tricky question. What's important to remember is that for some function, if you know it's differentiable at some point, then it also has to be continuous. It doesn't go the other way, though. Knowing that a function is continuous doesn't tell you that it is differentiable. However, if you know that a function is not continuous at a point, then you know it's not differentiable at that point. Okay? So those are the two things we know about a given function. However, in this particular statement, it says f prime is continuous for all real numbers. That means the derivative function is defined and is continuous for every single real number. So no matter what your real number that you plug in for x, you'll be able to get a derivative. In other words, you'll be able to find f prime for any real number. So then f of x is differentiable at any point. Well, this should be pretty obvious, because no matter what point you use, you're able to find a value of the derivative, which means clearly that f of x is differentiable. It's pretty basic, but the tricky part is noticing that this is actually saying f prime. Notice if this just said f of x is continuous for all real numbers, then f of x is differentiable at any point x equals a, That would not be true, because it doesn't have to be the case that a function is continuous, that it then has to be differentiable. Think of the absolute value function. So this particular statement is true. However, if this were just f of x and not f prime of x, it would not be true. And then here I made my sign chart. This is pretty self-explanatory, and then here's what my function looks like. Alright, so these last three are some pretty tricky questions that really push your thinking. So if you have some other things that you think you want to spend some more time practicing, I'd certainly go back and practice those before I'd spend time on these questions. The first couple are pretty straightforward. For number 2, for part B, how do you know it's continuous? Well, you're told it's differentiable for all real numbers, and if something's differentiable, then it is continuous at that value. For part C, is there a 0 of f, meaning does it intersect the x-axis on the interval from 2 to 4? And yes, it does, right? At 2, it's at -1, and at 4, it's at +3. And so by the intermediate value theorem, a continuous function will hit all values between any 2 that it hits. So it will take on all values between -1 and 3. Don't worry about part D. You need a rule that we haven't quite learned yet, called the quotient rule. And for part E, if you plug in 4, you will get an undefined value, which means that your function can't be differentiable at that point, right? Either it's going to be discontinuous, or it's going to be perfectly vertical at that point. And so it's going to have a horizontal tangent, which would mean it would be non-differentiable. For number 7, you'll want to use the binomial theorem in order to expand x to the n. And for number 8, what you want to do is use the same idea here, except you want to make a substitution where you say, let me call this variable m, and let me set it equal to -n. And then when you make that substitution into your expression, you'll be able to follow basically the same idea with a few little adjustments. And if you want to go over those, certainly come by and we can discuss them, but certainly should not be what you're focusing on unless you feel extra confident about everything else. All right, hope all goes well. I'll see you guys tomorrow.